Now there's one last complication to this whole story of increasing the concentration in the medulla. And that is that we said the concentration can get as high as 1200, sometimes even 1400, let's stick with 1200 though, 1200 milliosms per liter. And it turns out that about 600 of that, 600 milliosms per liter, is made up of sodium and chloride. But that's only half, so what is the rest? Well, it turns out that the other 600 or so is actually made up of something we've heard about before, which is urea. Now, how does all this urea get here? That's what we'll talk about in this video. If you remember a couple of videos back, we said that urea is actually reabsorbed a little bit throughout the nephron, but it's only reabsorbed a little. And what I mean by a little is it's reabsorbed much, much less than sodium and water. So this urea, of course, is dissolved in water, but a lot more water is being reabsorbed than the urea. And so what does that mean? That means that the concentration of urea as you go along the nephron goes up and up and up. Every time you remove water, you're increasing the concentration of urea. And so that means that actually by the time you get out here to the collecting duct, the concentration is actually quite high. And that could pose a problem because let's say that we had this very high concentration of urea here in the collecting duct, and then let's say that we released some ADH because we wanted to reabsorb a lot of the water out of this fluid in the collecting tubule. So the ADH is going to cause water channels to be put into the collecting duct, and that's going to allow water to get sucked out towards the high concentration here in the medulla. But urea is a solute, and so this urea sitting in the collecting duct is going to resist water going out. It's going to add solutes and concentration to the collecting duct, and so it's going to make it harder to get a lot of water out of the collecting duct. Now the solution to this that the kidney has is that ADH not only causes you to put aquaporins into the collecting duct so that you can reabsorb water, but it actually also causes you to put urea channels into the collecting duct. And so we get some urea channels here, and what do those do? Well, those allow urea to diffuse out into the medulla as well. And that urea actually accumulates out here to a pretty significant degree, and it can actually reach these high concentrations that we mentioned of 600.